Okay, we're looking at question 1. It asks you to graph the functions. The first thing I'm going to do is I'm going to go ahead and do the y-intercept. There's my y-intercept. My y-intercept is going to be negative 6 over 5, which is negative 1 point something, I don't remember, 1/5. So 1/5, so 0.2. Okay, there's my y-intercept. Okay, I can also go ahead and do the horizontal or slant. This one is, the powers are the same, so that is a Betsy, which means, what does the C stand for? Coefficients, which is 1 over 1, which is 1. Okay, so my horizontal is 1, my y-intercept is a negative 1.2. Good so far? Okay. Now I need to factor to see if I have holes or to see if I have vertical asymptotes and to find my x-intercept. Even though those items aren't listed, you should go ahead and find them because it makes it easier to map the graph. Okay, so two numbers that multiply to 16 and subtract to make negative 3. That would be 6, negative 6, and positive 3. Two numbers that multiply to 15 and add up to 8 would be 5 and 3. Now, I didn't write it as a fraction, sorry. What do you notice? There's a hole right at negative 3. So the hole is negative 3, comma, we got to plug it in. What's negative 3 minus 6? Negative 9. Negative 3 plus 5. 2. So this is negative 4.5 when I go to graph. Cool? You plug it into the remaining parts of the function. You do not plug it into the hole, because if I plug it in that's going to give me a 0 and everything cancels out. So it doesn't work, okay? So this piece left in the top is my what? The piece left in the top is what? X-intercept. It is my x-intercept. So x minus 6 equals 0. X equals 6 is my x-intercept. And I remember the bottom is my vertical asymptote because Virginia is south of Maryland. It is south of the Mesa-Dixon line, and it is below Maryland. Okay, VA is below Maryland. So x plus 5 equals 0. X equals negative 5. Okay. Now, my domain is everything except for what? Negative 5 and negative 3, right? It's not going to be a hole, and it can't be an asymptote. Okay? So I am fine with you writing all reals except for negative 5 and negative 3. Or you can do negative infinity to negative 5, negative 5 to negative 3, negative 3 to infinity. You can write it out the long way. I don't care which way you do it. Okay? I'm being a little lazy today, so I'm going to do the shortcut. So all reals except negative 5 and negative 3. Okay, my range. My range is going to be everything except for my horizontal asymptote. So it's going to be all reals except 1. Okay? The range, what is range? X or Y? Y. Okay, so, oh, sorry. No, except for 1 and the other part of the whole. So except for 1 and negative 4.5. Okay, so, yes? Yes. Correct, because a horizontal asymptote goes through the y-axis, a vertical asymptote goes through the x. Okay, so let's say it again. A domain will be everything except for vertical asymptote and a hole, the x part of the hole. Range is going to be everything except for the horizontal asymptote and the y part of the hole if you have a hole. Good? The vertical asymptote and the hole. Good? All right, so now we're going to plot it. Okay, so I have a vertical asymptote at -5. Boom, 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 boom. I have a horizontal at 1. Dot, 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 dot. Beautiful. I have an x-intercept at 6. I have a y-intercept at -1 and 2/10. So eyeball it, sorry. I have a hole at -3 and then -4.5. So if that's 4, that's 5. Right here, I put an open circle. Oh, that didn't, hold on, let me change the thickness of my pen. Okay, so there's that. Let me change the thickness of my pen. All right, so -3, it's because my grid isn't very big. -3, there's -4, there's -5, so a half. So there, you see my hole? It's supposed to be halfway between, sorry. Okay, good. So I marked this, I marked this, I marked this. I marked this. Okay, is there anything left for me to mark? No. Okay, so I'm going to be lazy graphing. So I'm going to connect these points because my graph should hug my asymptotes, right? If this is heading towards -infinity, the other side's going to pick up at +infinity, loop. Okay? Now, technically, you can pick a point over here, plug it in, and plot some of those points, but I told you guys could lazy graph. Yes? Correct. So if you remember, the numerator gives me the x-intercept. The denominator gives me the vertical asymptote. The constants give me the y-intercept. And the power of the first term gives me the horizontal. It tells me what case. Is it a Bob's, a Botu, or a Betsy? Yep. Yes, what's left if there's a hole after you cancel out the hole? How do I know if there's a hole? A factor that matches top and bottom. Good? Any other questions about properties before I move on? Good? Horizontal asymptote is based on the power of the first term. So if the powers match, that's a Betsy, so I'm going to use the Lie coefficients. If it's bigger on the bottom, it's a Bob's. So the horizontal asymptote is going to be 0. And if it's bigger on top, Botu, it's undefined, and we have to do synthetic division to find the slant asymptote. Okay? Which we will review. Good? All right. Okay, let's look at this one. So, first thing I'm going to do is I'm going to factor. This is x minus 3, x minus 1. So I do not have a hole. No, or none. Okay? Everyone good with that? Okay. Y-intercept is going to be what? 3/2. For graphing purposes, it would be 1.5. X-intercept. Where do I find the x-intercept? In the numerator. How many x-intercepts do I have? 2. X-intercept, x-intercept. What's my first x-intercept? +3 and 1. Please remember that this is a factor. You must set it equal to 0 and solve to have the x-intercept and so forth. Everyone good? Okay. All right. So what is my vertical asymptote? -2. Okay. I have x squared, x, a power of 2, power of 1. Where's the power bigger? Top. So that is a Botu, which means the horizontal is undefined. So I have a slant. So we are going to do the slant. If there is a remainder, we're going to ignore it. Okay? So I'm going to take the coefficients of the top. What are the coefficients of the top? 1, -4, and 3. And am I going to divide by +2 or -2? -2. The reason is, normally when you divide, you subtract. If I do the opposite, I don't have to do subtraction. I can do addition, which is quicker and easier. Cool? I'm going to drop the first term, 1. What do I do next? Multiply. Again, if you don't like synthetic, because I know many of you were taught law and division last year, you can use that. Negative 2 times 2. Negative 2. Negative 2 times 1 is negative 2. Oh, negative 2 times 1. Okay. Negative 4 plus negative 2. Negative 6. Negative 6 times negative 2. 12. So I do have a remainder of 15, but we don't care about the remainder, okay? All right. So my slant asymptote is going to be x minus 6. Remember, when I divide, I lose a power. So this was an x squared, so now it's a x. This was an x, now it's a constant. Okay? It's x minus 6. This is the work. Okay? The horizontal is undefined. The slant would be x minus 6 because we don't care about the remainder. And so you would graph that. You would graph a line that has a y-intercept of negative 6, move up 1, over 1, up 1, over 1. Graphing a linear line. Algebra 1, ringing a bell. Okay. All right. So, domain is everything except for vertical asymptotes and holes. So my domain is all real numbers except negative 2. All right, and my range is going to be all real numbers. We're just going to put all real numbers because it doesn't have a horizontal. We're going to go, for now, yes. Correct, you only do synthetic division when it's BO2. Otherwise, it's going to be 0, or it's going to be the lead coefficient divided by the lead coefficient. Betsy Bob's. The lead coefficient. So in the last problem, this was a Betsy. The lead coefficient's 1, 1. If this had been a 2x squared, then it would have been 2 over 1. Yes? Okay. All right, problem number 3. Even, odd, or neither. Justify algebraically. How do I do that? I put it, what? Negative x. So negative x squared minus 2 times negative x, absolute value. What happens when I square a negative? You get a positive. Okay, what happens when I take the absolute value of a negative? Still a positive. Okay? So is this an even, odd, or neither? Why is it even? Everything did the same, so even Steven. What happens if all the signs flip? Odd. What if some of the signs flip? Undefined. Be careful. Some of you missed that on the quiz a couple weeks ago. A constant can never change signs because you need a variable to switch signs, okay? Because a variable I can change out, which could cause it to change signs. If you're a constant, you have no variable, so there's no way for you to change. Good? Okay. So if an equation contains a constant, it can never be odd. It can never be odd. Also, it can't be odd because if it has a constant, the way it shifts, it takes it away from the origin. It cannot be odd if it has a constant. It could be even or neither. All right. Number 4, to me is like something you should have been able to do in algebra. It's just a plug in and plug in. Okay? So, a weather balloon rises. Okay, great. And they gave me a lovely equation right here. And what is the meaning of VR200? Volume of a balloon with a radius of 200? No. Volume of a balloon at 200 seconds. Well, because, remember, this is really V of R of T, right? Because they have a T here, and T is time. Cool? All right, so first thing I'm going to do is they've given me, yes. Oh, I just went with seconds because that's what somebody said. Okay. Oh, yeah, seconds. Sorry, but good point. Yes. Yeah, hold 1 second. Yes, I am. Okay, so 200 is time. Does this contain time here? No. Okay? I see time in a formula, so I'm going to start with the formula first. So I'm going to do 0.03 times 200 plus 48, which gives me 54. 54 is now my what? It is a radius, okay? Where do I see information about radii? In the table. Oh, right here it's 54. The volume is 659,249. Whole problem is now done. Cool? Yep, I went to the table. So this is one. Sometimes it's an equation and then another equation. Sometimes it's an equation and a table. Just know that when you get in the real world, you are thrown information in different formats, and that's just an exposure to that. Huh? On the RQA? No, I'm just going over this for the fun of it. Yes, if it's in the review, then you're going to have something similar that requires the same skills. It won't be exact, but it will require the same skills. I'm not trying here to torture you, okay? Yes. Yes, this will be on Google Classroom today. All right. I am up to question number 5. Now, this one is meaner than I've had you do in the past. Okay? So, we need to do f of g of x. So, that is going to be 2x plus 3 over x minus 1 plus 3 over x minus 2. Oh, we do. How did I totally miss that? Oh my gosh, I totally missed that. Sorry. You do plug it in the denominator. How did I miss that? Good eyes. 2x plus 3 over x minus 1. Okay? Woo, it's a lot, yeah? So we did do one like this. Now it's coming back to me. Okay, in order to add these two in the numerator, I need a, in order to, I heard it, common denominator. My common denominator is going to be x minus 1. Yes? How about in the denominator? How about in the denominator? Same thing. Because remember, this is 3 over 1, right? So I have a 1 versus an x minus 1. The easiest common denominator is to multiply the two together. Gives me x minus 1. Oh, sorry. Okay, cool. Because I was thinking about the number 3, about what I was going to talk to you about next, and I wrote that instead. Okay, so this becomes 2x plus 3 plus 3x minus 3 over x minus 1 in the top. Yes? I'm going to pick a different color for the bottom. Okay, the bottom is going to become what? You tell me. 2x plus 3 minus 2x. Oh, so close. Plus 2 over x minus 1. Now, who remembers the cool trick that I can do now and why? I can cancel out the denominators because they match. And when you divide, you multiply by the reciprocal, so it would have cross-canceled anyhow. So goodbye, goodbye. Now let's clean up the numerator. No, we got to simplify the numerator first. Yep, we combine like terms. So this cancels this, and I'm left with 5x, yes? Okay? In the denominator, what happens? I think this is what you were trying to say. The 2x's cancel here, and I'm left with 3 plus 2, which is 5. And 5x divided by 5 is x, 1x. So that is half of the problem. That is half of the problem. Now you got to do it the other way. This is the only super, super tedious problem. Yes. Your review is longer than the RQA. Because some stuff that's challenging, I put multiple examples of. I have to double check. All right. Here we go. Now I'm going to do g of f of x. So I'm going to do 2 times what? X plus 3 over x minus 2 plus 3 over x plus 3, x minus 2 minus 1. Okay? Now, time out for a minute. I want to take care of this 2. When you multiply a whole number times a fraction, it changes what? The numerator only. So I'm just going to erase this and rewrite the numerator if you don't mind. Okay, so then this is going to be 2x plus 6, yes? Okay, now we're back to the same process with the previous one. What is my common denominator going to be? X minus 2 over an x minus 2, and same thing on the bottom. Yes, it just worked out nicely like that, yes? Okay, so I already know what's going to happen. Let's just not spend the time doing it. What's going to happen? Everyone has the same denominator, so goodbye denominator, okay? So in the numerator, I'm coming over here, sorry. I have 2x plus 6, what? Plus 3x minus 6 over x plus 3 minus x plus 2. Okay, in the numerator, what cancels? Beautiful. In the denominator, what cancels? Okay? Because we're combining like terms. When combining like terms, items that are similar but different signs cancel. In division, you can only cancel factors. Okay. So this gives me 5x over 5. 5x is really 5 times x. So it has a factor of 5. I have a factor of 5 in the bottom, so it cancels. It does not make 0. Remember, division is, when they match division is 1. When they match in addition and subtraction, it's 0. Yes? Don't ever tell me 5 divided by 5 is 0. Woo! So I got x, and now I got x. They are inverses. Nice job. Woo! We survived it. I don't know. I haven't unpacked the test now. All right, so what law am I breaking? What's the law? Square root of a number cannot be? It has to be greater than 0 because it cannot be negative number. So x plus 2 has to be greater than 0. Come on. What do I do next? Minus 2. So x has to be greater than or equal to negative 2. It can be any value greater than or equal to negative 2. Okay, so that was 1 through 6. I did 9 and 13 the other day, but I will at some point re-record those in case you need to see them. Yes. Yes, you can. You can always come in at lunch. You can come in the morning. A couple of you came in this morning. I appreciate that. Okay, so that leaves us 7, 8, 10, 11, and 12. Yes? 7, 8, 10, 11, 12. That is homework. Get started.